whatever, you have to have the capability and the knowledge to be able to hand crank these pumps if need be. So doing it is fairly simple. You have to disconnect this from the back of the console, and there's a little clip under here that clips down, and this little lip up here clips into the top side of the pump. There we go, it's got a bit more forceful. So if you've got a veno-arterial ECMO case and the pump stops working, what's going to happen to the flow rate? It's going to go to zero, but remember there are no valves in the circuit, okay? So you've got an open conduit between the femoral artery and the femoral veins. What's going to happen? Yeah, you're going to get reverse flow through the circuit. So first thing you do is clamp the circuit, okay? It also means that you've got to have a certain RPM rate to even have zero flow. So because the pump is working against an afterload, you've got to have maybe, depending on what the patient's pressure is, maybe have an RPM rate of maybe 1800 RPM just to have zero flow. So before you go onto ECMO, you've got to have the pump lines clamped, turn the RPM rate up, and then open the clamps. So turning this is actually fairly easy. It's a little bit, this is actually quite easy to do when this is actually fixed onto a pole. But we've got a little light on the top here that indicates what RPM rate you're running. So whatever the patient's baseline rate was, you have to match that with your hand crank. So this should always be set up and accessible at the patient's bedside. So I'm going to clip this back in. Now there are a few other things that this pump does that make it very, very user-friendly. The first is that it has some internal pressure sensing. This is a little pressure transducer here that actually plugs into the pump over here. And what this pressure does is measures the pressure between the pump and the oxygenator. That's called the pre-membrane pressure, and that's the highest pressure part of the circuit. The other pressure you want to know about is the pressure distal to the oxygenator, which is called the post-membrane pressure, and this pump will give you the gradient between the two of them, so it'll give you the transmembrane gradient. Now as you get progressive pump failure, which can happen over several weeks, your transmembrane gradient may go from 15 or 20 millimeters of mercury to 50, 60, and keep climbing. Now if that's starting to happen, you may need to consider changing the ECMO circuit. The other thing that these new pumps give you is integrated flow probes. This is the flow probe over here. And this also is an inbuilt air bubble detector. So it'll tell you if there's an air bubble in the circuit. The ECMO software shouldn't stop the pump in response to that, though. These pumps can be used as heart-lung machines in cardiac operating theatres. If there's an air bubble from the surgical field, the pump needs to stop in response to that, so you're not producing a massive air embolus back to the patient. But for an ECMO patient, these bubbles are likely to be very small, and while you might want to know about them, you don't want the pump to stop under any circumstances, because if it does, VA cases, you're going to have acute backflow through the circuit. VV cases, if you've got a patient that's fully ECMO dependent and has no lung function at all, how long do you think it might take them before they arrest? Usually about 30 seconds, because they've got no FRC. As soon as the pump stops, they're profoundly hypoxic, and typically they'll become asystolic within about 30 to 60 seconds. So if you are changing the circuit, you need to be quick, and so be prepared for that. The other sensor this has, which is very useful clinically, is this sensor here, which measures the saturation in the venous line. So it's analogous to mixed venous oxygen saturation. So it's a useful sort of global marker for the patient's perfusion state. And this also has an inbuilt hemoglobin or hematocrit sensor as well. So you get continuous hematocrit, continuous mixed venous oxygen saturation, internal pressures, temperature, it gives you the temperature of the patient as well, and all that with a battery backup, which is good usually for about at least an hour or so on this pump. So the other great feature about these pumps is that it's very easy to prime, and when we turn the pump on, we have a dry circuit initially, and the first thing we do is zero the pressures while the pump is dry. We've already done that for the last case, so I can't show you how to do that. We'll just shut these alarms up because they're very annoying. There we go. So that's overriding the alarms. So this is our home screen here. There are different screens that are available. On this particular screen, you get flow rates, RPM rates, venous pressure, so pressure in the inflow side of the circuit, and temperature, mixed venous oxygen saturation, hematocrit, and you can select whatever screen you like, but these will show you different modalities. This one will show you mixed venous saturations, arterial temperatures, hemoglobin and hematocrit. But this home screen is probably the most useful one because it gives you the most clinically useful information. So once the circuit's all set up, you've got your pressure zeroed. The next thing you want to do is prime the circuit. And it comes, here's Deb, here's my IV pole. So this is actually very, very straightforward because this circuit comes with some one-way valves. There's a little duckbill valve here that's one way. And so all we do is start the pump running. We've now re-established flow. And now we've got flow around the circuit. And what you can see here is you've got your flow rate being demonstrated. You've got your venous pressure being demonstrated over here. And as we vary the flow rate, what you'll notice is the venous pressure changes. Okay, so and because this is a non-collapsible tubing, we can run this very hard without any problems, but we're just generating more pressure in the venous line as we do so. Now you can imagine that if you have a vena cava that's exposed to those sorts of pressures, it just collapses down. You're and we've got some bubble sensors which can now reset because we've reprimed the circuit, and smooth sailing. So here's a bubble that's just been detected in the circuit, and as I said, the pump shouldn't stop in response to that because we don't want it to. And so in ECMO mode, with the various modes that can be selected for these pumps, we can clear that bubble and keep going. So as I mentioned before, when you go on with these cases, the first thing we're going to do is have the lines clamped, have the circuit's going to be primed, and what we're going to do then is to open the circuit. And what this, again, circuit very cleverly does is that once you've got the circuit fully primed, you can then clamp your prime lines and clamp these lines as well. And there's a little handset connector here, which I won't do right now because I can't demonstrate the priming to the next group. But we disconnect the circuit at these 2 points, plug it into here to form a loop. And this loop gets handed off to the person who's doing the cannulation. Then connect the loop to the cannula, and away you go. Got a couple of little clamps here that we can use to facilitate that process. So we can clamp that, and clamp that. We can clip this, double clamp that, and actually we'll show you how to do this. These just pull apart like this, and this one pulls apart like this. Plug these together, and away we go. And now there's a little de-airing port here, so if you do have any air trapped in the circuit, this will come out through the top of this little yellow port over here. And once the circuit is fully de-aired, we can then close that port and stop any further air escaping. So any questions about that?
How much do they cost?
The pump costs about $100,000. The disposable costs about $5,000. So per case, yeah. So this costs about as much as a pacemaker, in terms of disposable costs. So we've got 3 of these pumps at Prince Alfred Hospital and 2 or 3 at St Vincent's Hospital as part of the state retrieval program. There's a couple in Newcastle and a couple in some private hospitals as well.